Hello, I'd like to talk today about a new operator that we'll be releasing in the platform soon that is called Create Finite Element Mesh. So the purpose of this operator is to convert polylines into a volumetric mesh, which can then be used for finite element analysis. So we convert the geometry into a volumetric mesh that is stored as a VTU file that contains all the volumetric data, and then this can be used by our own developed thermal simulation, or in the future users will be able also to export it and run simulations into their own third-party software. Another use case of this operator is for more design-oriented purposes, where the geometry can be used as a triangle mesh to give this kind of pixelated result, and then this can be directly sliced and printed if a user wants to. So here in the example that I'm sharing, I have loaded the geometry of this bunny model. I have then sliced it and have generated multiple walls, infill and skin to make it solid, and then I passed this sliced output into the Create Finite Element Mesh operator. So here we give a few options to the user to customize the result of how they want the volumetric mesh to be generated. The first option that we have is the enable base plate that allows the users to generate a base plate around the geometry, which is typically needed for finite element analysis. And if I enable it, we see that a few more settings become visible. So the first setting is called base plate shape, where the user can choose among three different options. One is the option to generate a square plate, then there's also the option for a circular one, or they can also provide their own geometry for custom results that could be useful in cases of printing on a non-planar base. So let's try the square. Now we see we can define the size in X and Y dimensions of a base plate and also its height. For now I'm going to keep the default values and click on compute. And this is the result that we get. And if I were to select the circle, then the user can specify the radius and the height of that circle, which looks something like this one. Then we also have control over the element sizing or voxels. So for that the user can specify them in two different ways. One is based on the size of these elements, and the other is more automatically based on the bit ratio of the polylines that are passed as input. So in this video I'm going to focus on the size option, and then here we have some more options. So I have enabled the option for cubic elements, meaning that each voxel will have the same size in X, Y and Z directions. And then here we specify the built element size in millimeters. So in this case we see that each voxel has a side of 5 millimeters. So if I zoom in a bit and I change the display mode to edge faces, here we can see more clearly the individual voxels. So if for any reason I wanted to have different dimensions for every voxel, I can disable the cubic elements. Then some different options become available, and I could specify a different value for the dimension in the X, Y and Z directions. So I'm going to change the built element size in X to 6 millimeters, same for Y, and I will leave the Z in 3 millimeters. And if I click on compute, okay, we get something that looks like this. Again, if I zoom in, we can see now how the Z side is half that of X and Y. So that is a brief overview of the capabilities of this new operator, and I would like also to show you a different example and different geometry in which we run this. So here we have this parametric chair that we have then sliced. Again, we generated here multiple walls, infill and skin, and then passed it inside the Create Finite Element Mesh operator, and this is the result that we got. And now this is easily to be passed into another software or our own module for finite element analysis, or export it and slice it to be printed in this pixelated kind of geometry representation. Thank you.